All right, friends, we have made it to our always, sometimes, never true section. So this is a little bit tricky. This is something that people struggled with on the quiz for true, false. Always, sometimes, or never true. So if we're going to say always, that means that 100% of the time it always works. I know that you'll know that, but it has to be true in all cases. So no matter what picture you draw, it has to be true. Sometimes is where you have one picture that works and one picture that doesn't work. Never is where you can find no picture that works ever. Okay, so it's just absolutely an incorrect statement. All right, so here's the deal. If in doubt, you're going to draw it out. We had a lot of people on the quiz that were just guessing on these problems. This is just one of those logic things where if I just turn these into just direct statements and I said, what is the same ray as GH, you'd probably be able to do it looking at a picture, but this is you actually having to reason through it. So we're actually starting to work on our reasoning here. And so before you ever answer a question, I want you to draw pictures. Okay, so we're seeing is this always, sometimes, or never true? GH and HG are the same ray. Okay, so let's draw ray GH. If this is point G, and if this is point H, GH is the one that is a flashlight. So I'm going to highlight. Y'all know I like my flashlight pictures. So let's do this real quick. So I'm going to do this real quick. Here we go. I'm just going to put them on a line. Okay, so ray GH, that is the one that is a flashlight coming out of G, and it has the light shining through H. Is that the same flashlight? Is what it's saying. Is that the exact same flashlight as the flashlight that is starting at H? Okay, so this one came out of G and shined through H and beyond. Is that the same flashlight as the one that's starting at H? Well, I'm already recognizing this is a different flashlight and shining through G. Well, those are two totally separate flashlights, okay? If you had two people having a flashlight tag war, they'd have to have two separate flashlights shining at each other. That would not be the same ray. So can those be the same ray? That is going to be a never true. For two, let me just give you an example. For two rays to be the same ray, they have to come out of the same source of power. So that since this starts at G and this starts at H, you immediately know that those rays are not the same because they'd have different endpoints. This one starts at G, this one starts at H. Let me give you an example of things that would be the same ray. I'm just going to draw you a picture real quick. If I had letters on here, we'll just do my initials, EBH. EBH. So what would be an example of the same ray? Well, the same ray would be like EB, shining E through B, and then starting at E, going through H. If I had somebody that was holding a flashlight at E, there's my flashlight, you can kind of see the picture, and shining through B, that'd be the same flashlight as the flashlight starting at E, shining through H. So notice that those both would come out of the same source of power and shine the same direction. That would be the same ray. But because that's not the case here, we have GH and HG. Those are two totally different rays. Okay? All right, let me just give you some feedback. I'm just seeing if those are okay. Now, if I said line GH and line HG, those would be the same line because lines, you can reverse the order. If I change these to segments, if I said segment GH and HG, you could say that those are the same, forwards and backwards, left to right or right to left, totally fine. What can you not do that with? You cannot do that with rays, okay? You cannot do that with rays because you have a starting point and then it extends it forever in one direction. They have to come out of the same starting point. So that, just draw out those pictures and see those are two totally separate flashlights. All right, this was a commonly missed question on the quiz. Any 2 points are collinear, meaning if I put a point here and a point here, can you connect them with a straight line? Is there a laser that you could shine through them in a straight path? And the answer, oh goodness, is there a laser you can shine through them in a straight path? And the answer to that question is yes. Through any 2 points in this world, you can form a straight line through it. So any 2 points are collinear. That is always going to be true. That is 100% true all the time. Now, you might say, but Ms. Hall, if I put letters on this like A and B and C, now C isn't on the same line as A. It is not until you draw in the line. We know that there's a line that exists there. And so now it's on the same line. Where people get confused is you say, well, Ms. Hall, B, A, and C are not on the same line. And you're right. If I connect from B to A to C, that line, we'd have to bend it, and obviously that's not a straight path. And so if you use 3 letters, you have to pay attention. In this case, B, A, and C would not be collinear. And then if I moved point D here, B, A, and D would be collinear. But through any 2 points in this world, like B, A to B, any 2 points, no matter where they're at, if I put one on the ceiling and one on the floor, there'd be a straight path that you could shine through them. So any 2 points in this world are going to be collinear. Okay? So if there's not a line there, we know that there's a line that exists through those 2 points. So any 2 points, that's always true. Okay, a plane contains only 3 points. So let's just draw ourselves a picture. A plane contains only 3 points. We know that when we name a plane, we need at least 3 points, right? A, B, and C. Okay, so yes, that forms a triangle, A, B, C. That would help me name that plane. But are those the only points that live on that plane? No, we know that there are infinitely many points. I could add another point and call it D, or add another point and call it E, or add another point and call it F. There are a whole bunch of points on that flat surface. It takes 3 points to name a plane. If I said through any 3 points a plane exists, you'd say true, as long as they're non-collinear. So that would be if I said through 3 non-collinear points. So if I said if you have 3 points that do not form a straight line, a plane exists. That's where you would say true. But if I said there's only 3 points on that plane, then you would say false. Okay? A plane contains only 3 points. That is never going to be true. It takes at least 3 points to name a plane. Through any 3 non-collinear points, a plane exists. Now, if you were to put them in a straight line, a plane does not exist that forms a straight line. But through any 3 non-collinear, meaning they form a triangle, the plane not only exists, but once you create that plane, there's infinitely many points on it. So there's a ton of points that make up that plane. All right, this next one. If 3 points are collinear, then they are coplanar. So let's figure that out. Let's put 3 points in a straight path. Let's connect them with a straight line. Okay? If those 3 points are collinear, all in a straight line, then they are coplanar. Meaning, can I draw a plane around this line so that all 3 points are going to be on it? Well, yes, I can. I can do it like this. And you're like, well, Ms. Hall, what if I only got 2 of them? Well, what do we know about planes? Planes extend in all directions forever. So this would keep going, keep going, keep going. So you can picture it like on this sheet of paper. If I were to draw 3 points, another way to explain this, think about your desk. Okay, so you've got your desk. Your desk is a rectangle. If on your desk I had you put 3 points right now, let's call them E and B and H. If I had you draw 3 points on your desk using a pencil, and then I were to ask you, are they on your desk? Or do they form a plane? You would say yes. You'd say, hey, this is a triangular surface right here. It extends forever in all the directions. If they are coplanar, then they are going. If they are collinear, they're going to be coplanar. So the ones I just did were in a triangle. So now let's get more specific, okay? So if we draw 3 points on our desk, those are contained in a plane, E, B, and H, right? So now what they're asking is take those 3 points and put them in a straight path. So E, B, and H. Okay, so it's a little bit more specific. They say if these are collinear, if we know that they're on the same line, does that mean that they're coplanar? And so that would be an always true. If 3 points are collinear, they're also going to be coplanar. They're contained in the same plane. So if you were to draw a line on your desk and put 3 points on them, that line not only is on your desk, but those 3 points are also collinear. Okay? All right, so that is that next section. That is tricky. We'll be practicing that a little bit more as we go. And then we're going to do a chapter 2. We're going to do reasoning and proof, where we do a lot more reasoning that involves determining whether statements are true or false.